Okay, in the last session, we looked at control flow statements, which were essentially the if, else if, and the switch case structure. Now we'll move on to the other type of control flow statements, which are called the iterations or loops. Okay. So why do we need, first of all, what is the need for an iteration or a loop? In computation, you will generally see many a times, we do the same operation for different sets of data. For example, if you're kind of computing something for a set of students in a class, so you probably do the same operation over and over again, right? So in general computation, you will see that there is often repeated actions on different sets of data. So that's a fundamental construct why we need something like a loop, right? So loops are really useful when we want to do something repeatedly. So I've just given some other examples also here. Like for example, you have a string and you want to convert whatever is lowercase into an uppercase, right? Which means you have to do the same operation for every character in that string. So which is naturally you can imagine that if I can have a same logic but somehow execute it every time, the only change in every iteration of the loop, iteration is one pass of the loop, is that I'm looking at a different character, right? So that's something which we can do. Or so that's essentially a simple example of why loops are useful. So almost all modern programming languages will support some type of a loop construct, which gives you a way to kind of go through a series of data points and do the same action one by one. Okay, so that's a basic need for a loop. Okay, we'll then move on to seeing some examples of what are the type of loop statements that the C language supports. Okay. So the first loop structure that we will see is called the while loop. A while loop structure is very, very simple. As you can see here, the structure it starts with while. While is a keyword here. While an expression. As long as this expression is true, this statement will be executed repeatedly. Okay. Now, this statement, as we have seen earlier, right, a statement, when I say a statement, it could be one single statement with a semicolon, or it could be like this, a group of statements between this curly braces, which is like a compound statement, right? Okay, so anytime you see a statement, you can imagine it's a single statement or a compound statement. Okay, now that's the basic structure, right? Now, what are the things that you can imagine? Suppose say I have a expression. Let's take an example of converting something into this is not a basically we want to kind of print a set of characters starting from A by using the property that in ASCII the values from A to Z are consecutively increasing numbers. Okay, so what are we doing? We are starting with we have one variable called I where we are initializing it to 0, and we have this character variable C which we are initializing to this character constant in single quotes A. Okay, and I am running this loop. I want to run this loop for 26 times. Okay, so what I am doing, I am treating this variable I like my loop counter variable. Okay, so the condition, look at this condition. The condition says as long as I is less than 26, run this loop. Okay, and inside the body of the loop, we are essentially just printing C. Initially, when I print, because the initial value is initialized to A, so you will get A printed here. Then I'm incrementing I. Okay, I plus plus. This is the increment operator that we saw, and I'm also incrementing ASCII. I'm just doing it in two different ways. Here, I'm just saying C equal to C plus 1. In fact, C plus plus also would work, but I'm just showing you two different ways to do it. So now ASCII value of C is incremented by one code point. Basically, in the ASCII sequence, right? A is I don't remember what it is. I think it's 65. If I remember for A. So B is 66, 67 is C, and so on. So basically, characters as we saw are nothing but small integers, right? 8-bit integers, you can imagine. So if I increment it by one, the new value in C is going to be 66, which is nothing but the ASCII code point for B, right? So you can see the loop body is from here till here. Okay, so it starts here, it ends here. So the way it works is after this statement, you are reaching the end of the loop. Okay, so the control will go back and check this condition again. Okay, now what is the value of I? I was initially 0, right? Because of this I plus plus, I became now 1, right? And the check is 1 less than 26. Is it true? It's true. So it enters the loop again. Now it will print C, the new value of C. Let's write the values of A and C here, right? C was initially say 65, now it is 66. So when I say print of percentage CC, it is now going to print B here. Okay. Then again I increment I, so I became 2. C is also getting incremented, C becomes 67. So we reach the end of the loop. So it goes back and checks the condition again. What is the new value of I? I is 2. 2 is still less than 26, which is true. So as long as this is true, it will enter the loop again. Now I'm printing percentage CC. C is now 67. So here C will get printed on the output. I gets incremented, it becomes 3. C gets incremented, it becomes 68, and so on, right? Now, when will this loop end? The moment from 0 till 25, right? 0 to 25, when you are reaching 25, if you remember, whatever it is, you would have printed Z, right? 0 to 25 is 26 items, right? So we run the loop from 0 to 25. So 26 times we are printing. We are starting the print from A. So Z also would have got printed here. Whatever it is, Z would have got printed here. Now, when C became 26, I less than 26, is that a true statement? 26 is not less than 26. It's equal to 26, right? So this condition is becoming false. So it will jump to the next statement after the while loop. What is the next statement? Next statement is coming here. Okay, assuming this is the end of the program, that's how the program will exit now. Okay, when you come to the last statement in your main function, the program will stop. Program will come back to the operating. The control will go back to the operating system. So the program ends here. Is that clear? So this is the way a typical loop runs, and good way to understand a loop. If you see a piece of loop way to understand it step by step is to do something like this, trace the loop, right? Write down all the variables inside the loop. In this case, we have variables I and C. So just see what is happening in every iteration of the loop. You'll be able to understand how many times the loop is going to run. So this is called tracing the code. Trace through every instruction in that loop to understand what is the actual output of the program. So few things to understand, right? What is very important. Suppose say I forgot to do this. If I++ is not there in this loop, what will be the effect? If I++ is not there, this actually becomes something like an infinite loop, right? Because it will enter, C is getting incremented, so it will print probably A to Z properly. After that, if there is a meaningful code point, maybe capital A to something might get printed. It will keep printing after that, some garbage will start getting printed. But the loop will never end because I is not changing, right? If I don't modify I inside the loop, I is going to be 0 all the time. C keeps getting incremented. It may look like it's working fine for a while, but then you will see the program never ends actually, right? So that's called an infinite loop. So important thing in any loop is you should have a proper loop terminating condition, right? In this case, the variable which controls the loop. What is the variable which is controlling the loop? I is the variable which is controlling the loop. It could be a more complex condition also, right? This is a very trivial, simple example. But you could have, this need not be just a simple I less than 26. I think in this case, we have a very simple condition, but it could be anything more complex. It need not be just a simple one condition here, right? I could have done something more actually. I could have done I less than 26, maybe and something. If there are some other variable, I could have checked, x greater than 5 or something like it. Could have been any complex condition. So that whole thing should give a true or false value. So essentially, or in C terms, it should give a value which is non-zero. The moment this expression becomes non-zero, it actually becomes a true condition. Okay. So sometimes you may, if you had a down counter, right? Sometimes I may start with 26. I could have initialized I to be 26, right? And I could have just said while I, and the loop I may just do I minus minus. So what will happen is this will keep running till become 0. Once the moment I becomes 0, the loop will exit. Sometimes people write like that, right? You use the property that in C, anything other than 0 is considered a true value. So that's other way to write the same. So essentially, this whole expression should evaluate to a true or false kind of a condition, and the loop will keep running as long as this expression is true. The most important thing is when you write a loop, you have to make sure that there is some point at which the loop will terminate. So you have to make sure the variables that you're using to control the loop get changed within the loop appropriately as per the logic that you want to design, and make sure that the loop ends, right? One of the common programming errors where programs hang or whatever is loops, not having a proper terminating condition. You might have assumed some things, but it may not be happening. So even for example, if you're writing an embedded code, right, you may be like sometimes the whole embedded program itself is run like a while continuous loop. But in some other cases, you may be probably going and waiting for some condition to happen, right? You may be waiting for some value to be coming from the register or a data to come from a serial port or whatever. So you may be in a loop. But if you don't design it properly, sometimes you may be stuck in the loop. Say there's a hardware failure, the data is not coming. So normally you should have some mechanism. You should probably have some count to periodically come out of the loop and check something else. So there should be some recovery designed, into the loop structure, right? So especially if you're dealing with some external, when you write an embedded program, you may be checking some external things. See, here it's all in the program control, right? Here the variable is all in the program control. It is easy to predict what is happening if you look at the logic. Suppose I'm going and reading a register and I have a loop saying, while this bit is 1. Sometimes it might become an infinite loop if the data is not coming, the device is plugged out or something like that. So you should have, and if your whole embedded program is a single thread of control, you may actually have a system which is not responding because it's stuck on some register which is not changing its value, right? So you may have to have some things. That's where things like timers come in. You may have a timer which periodically comes and resets. If somebody is waiting in a loop, it should probably generate some interrupt and make sure things recover. So or sometimes you don't continuously keep doing the same thing. You have a count. I check say maybe 50 times. If it doesn't come, I abort and say like data timed out. I timed out because the data didn't arrive on time, right? So when you design an embedded system, you have to be careful because it's very easy to make this mistake of writing a loop, assuming everything will be good. See, it will work in the normal conditions. The problems will typically come when something abnormal happens. The other side device is not working as expected or whatever, right? Then you will get into a situation where you might be in an infinite loop. So it's good to remember this. So in any loop, make sure the termination condition will be hit. Especially in embedded system design, make sure that you are not assuming that everything will be fine, especially when you're reading external registers and so on, right? Which depends on external inputs coming in. So that is the simple example that we saw. Let's then we'll move on to the next type of loop, which is called the for loop, right? For loop is it has a few more steps actually. It's you can say one step more functionality embedded into the loop itself. So the basic syntax is like this: for is the keyword, and you have to put this brackets. Then you have typically 3 expressions separated by semicolon, and the statement. As usual, the statement could be a simple one-line statement with a semicolon or a compound statement, right? The easiest way to understand this is to map it to a while loop syntax. Okay, so you can imagine this to be expanded like this. See, expression 1 is something which happens before your loop starts. So typically, before you start any loop, right, you will do a lot of initialization. For example, if you look at the previous example, you can see I initialize these variables I equal to 0, C equal to A, right? I did this before entering the loop. So those are typical initialization steps which you will do in most loops that you write. Okay, so in a for loop, you can actually kind of embed it right here, and that's why when you look at the equivalent while structure, expression 1 is nothing but all your initialization conditions. Is that clear? Okay, and expression 2 is exactly same as the expression inside the while brackets. I mean, whatever you check, right? So expression 2 has to be true for the loop to continue executing. In additional, you have this expression 3, which may not be explicit in while loop, but this is there as part of every loop. At the end of the loop, like after you do all the logic in your loop, you come and increment some things, right? In our example, you can imagine it to be something like this, I plus plus or whatever, right? What we wanted to do was just print this, but to go to the next iteration, I have to increment this loop counter and also move the ASCII value, right? So that could typically be treated as something like this. So expression 3 is something which you do at the end of all the logic that you want to do in every loop. Okay, so that is the for structure. Basically, you should have 2 semicolons, and the expression 1 will come first, which is typically expression 1 essentially is executed only once. So to understand, expression 1 is always executed only once before entering the loop for the first time. After executing expression 1, expression 2 will be checked. So only if expression 2 is checked, the loop will be entered. So in both while loop and for loop, right, the loop can execute even 0 times, because the first time you check, that's one important thing to remember. First time if you check, if expression is false, the loop will never be entered. Okay. So similarly in the for loop also, if expression 2 is false, the for loop will never be entered actually. Okay. Once the loop is entered, all the statements will be executed. After executing all the statements, expression 3 will be executed. Okay, is that clear? So that's the difference between a while loop and a for loop. You'll see for loops quite often, especially when you're dealing with arrays and all that, because it's very easy to map all the array indices. You'll always initialize it in the initialization condition. So you'll typically see for loops quite often. And let's look at the same example as a for loop. Okay, so this I already explained. So you can say expression 1 and expression 3 typically are assignments of function calls, right? Okay, expression 1 typically you will kind of do some basic assignments, and expression 3 could also be simple assignments. Sometimes you may make a function call to maybe do some things at the end of every loop. And expression 2 is typically a relational expression that evaluates to either a true or a false. Just like in while condition, it has to give a while or true or false condition. And the for loop body is executed as long as this is true. It's very similar to the while loop here. And expression 1 is typically used to set up the initial conditions before you start any iteration. And expression 3 is typically used to modify some of the variables that are used in the iteration, or to refer to consecutive elements or whatever, right? So that's the typical structure of a for loop. So let's see some example here. I think the same code, we can look at how to write it as a for loop. So same printing multiple characters, right? You can write it as a for loop in this fashion. So look at what we are doing here. We are doing I equal to 0 and C equal to t, and note this comma. This comma is actually called as a comma operator also, but mostly you will only see it. The most common place where you see it is in initializations inside the for loop. So basically one by one all the things will be executed. So I equal to 0 will be executed. Then C equal to the single quote A will be executed. So this is done before the loop is entered. And since I is 0, now this check is going to be true. Okay, because this is checked after this initialization is done. 0 is less than 26, so the loop body is entered. The loop body, all we are doing is what? Just printing C. So A is getting printed. Now, once all the statements in the loop body, right, in this case there's only one statement. Assume there are 10 statements. After all the 10 statements, once you see this closing curly brace, which means you have reached the end of the for loop, at that time, expression 3, whatever is there in expression 3 will get executed. So after reaching this point, I and C get incremented. So I becomes 1, C becomes, if it was 65, it was 0 and this is 65, C becomes 66. So this is I and this is C, right? So 0 became 1, 65 became 66. After expression 3 is executed, now it will evaluate this expression 2 again. So 1 is less than 26, so enter the loop again. Print C, now B will get printed. Then I'm reaching the end of the loop, so again it comes here. So it becomes 2 and it becomes 67. 2 is less than 26, enter the loop again. C gets printed and so on. So the moment, as in the previous case, once 25 comes, you will actually be printing C is here. Once it becomes 26, now this condition will fail. So control will go beyond the for loop, right? After the for loop ends here, so whatever statement is here, that will get executed. Is this clear? How a for loop works? So the only thing to remember is there are 3 parts in this structure here: expression 1, expression 2, expression 3. Expression 1 is all initialization conditions. Expression 2 is a condition check. Expression 3 is run at the end of every iteration. Okay, once you remember that, it is fine. One more special condition is there. If you put something like for semicolon semicolon, this is a special case which is like an infinite loop. So if I want to write an infinite loop for some reason, right? Some embedded systems, you have an infinite loop which keeps doing the same thing again and again. You can construct an infinite loop by putting 2 semicolons. This is another way to write an infinite loop will be to put something like while 1. If I say while 1 is non-zero, right? So it's a constant expression. So this is going to be always true. So this is one way to write it, or you can just say for semicolon semicolon also is considered to be like an infinite loop. It's a special condition the compiler understands, so to treat it like an infinite loop. Is this clear? How a for loop construct works? And loops can be nested, right? Often you will have nested loops, especially when you, one of the common things you will see when you do mathematical programs and when you're dealing with things like 2-dimensional arrays and all that, you will often see a nested condition. So nesting works, basically the way to understand a nested loop is, so look at this loop. For example, what are we trying to do here? We are having a variable I, assume I has been declared somewhere here. I equal to 1, I less than or equal to 10, I plus plus. So basically I start this loop with I equal to 1 and enter the loop. I am just doing one print of a new line character, okay? So a new line gets printed, assume I come to the start of a new line. And then what is the next loop? There's one more loop variable called j, okay? So I am initializing j to be 0, and till j is less than I enter the loop, then j plus plus, and inside the loop, so let's look at the initial code. Let's write I, j so that we understand what's happening, right? Let's write I and j here. I was initially 1, okay? So we printed this new line character, assume I have come to this new line here, okay? And I enter the second loop, right? So this second loop
This entire second loop is part of the body of the first loop. Okay, so the first loop starts here and the matching curly brace here. This is where the first loop ends, or in a nested case we call it as the outer loop. Okay, the other term for the first loop in the nested condition is an outer loop. Okay, so we printed this new line character and we entered this loop. We initialize j equal to 0. Okay, j becomes 0 here. Now what is the condition? J is less than I, right? Is j less than I? Yes, j is less than I. So I enter the body of the loop. So I print an asterisk character. So on this line here, let's start this new line here. I'm printing one star symbol here. Then at the end of this loop, basically this is the only statement in this inner loop. This is the inner loop. Okay, so where I'm printing the asterisk symbol is the inner loop. After printing this, I reach the end of the inner loop here. So expression 3 of the for loop will get executed. What does it say? J plus plus, right? So j became 1, right? And then this condition is checked again. Is j less than I? No. So this loop has to exit. So when this loop exits, control will come here. Are you seeing, following me? Control will come here, which is after this inner loop. And there's no statement here, and you hit the end of the outer loop here. Since you hit the end of the outer loop, control will now go here, right? Expression 3 of the outer loop. So what does it say? I plus plus. So now I became 1. Okay. Sorry, I became 2. It was already 1. So I became 2. And after expression 3 of the outer loop is checked, again you'll check this, right? I is less than or equal to 10. I is still less than or equal to 10. So I enter the loop. What I do, I print a new line again. So I assume I started printing here. Now my cursor has moved to the next line, right? Now I enter the second loop. Second loop, again, what do? We reinitialize j to be 0. So now j is again becoming 0. Okay. J becomes 0. Is j less than I? Yes, j is less than I. So I enter the loop. What do? I print star here. So in the second line, when star gets printed, I come here. The second loop, inner loop has ended. So I go here, j plus plus. So j becomes 1. Okay. And then expression 2 is checked. Is j less than I? 1 is less than 2. So it is true again. So I enter this loop again now. I print another star. So the cursor was, after printing it, the cursor will be here. One more asterisk gets printed. Then I come here. This loop is ending. So I go to expression 3 of the inner loop. So j is incremented again. So j becomes 2. Okay. So j became 2. Now j less than I. I is still 2, right? 2 is not less than 2, right? So now the inner loop ends. Control comes here. We come to the end of the outer loop. Then we go back here and I gets incremented. So I now becomes 3. Okay. I became 3 now. Okay. I is 3. And then this check happens. Is 3 less than 10? Less than or equal to 10? True. So it comes here. New line is printed. So the cursor moves to the next line. And then again it enters the inner loop. So j is again becoming 0. Okay. And j is less than I, as 0 less than I. So then I print an asterisk in this new line. And if you follow the logic, you will see, in this case, you'll print 3 stars and so on. So it'll keep going till, I becomes 10. So basically the program will end after printing, 10 stars in this line. Because after that, when I becomes 11, this condition will be false. So the outer loop itself comes out and the control will come here, and that's the end of the program. Is that clear how the logic works? So anytime you see a loop, always take a paper, pencil, take a sheet of paper, write down all the variables in the loop, right? And trace the program. Then you will be very clear about what is the logic that is being implemented, right? Trying to understand in our own head, it's a very simple thing you can understand. The moment it gets more complex, when you have 3 or 4 variables which are changing, it's always a good programming habit. I mean, as a programmer, when you're especially reading some code, or you wrote a loop, it's not working, right? How do you debug? The best is to take a sheet of paper, take a pencil, write down all the variables like in a column, step through the loop one by one, instruction by instruction, line by line, modify all the variables. Then you'll be very clear where the problem is and you'll be able to debug that. So debugging is all about having patience, stepping through the code, taking a sheet of paper and doing it. You'll be able to fix it, right? Okay, so it's very easy to make mistakes when you write a loop because our mind will be thinking something, but by the time we write something, we will miss some corner conditions or whatever. So it's always a good programming practice to step through the code. If you are trying to understand somebody else's code, right? Often in the industry, you'll be looking at code which has been written by somebody else. It's always a good thing to go through slowly, step through the code and understand. Once you do that, you'll be very clear about what's the functionality in the loop actually. Okay, so that was the example of a nested loop. Okay, then we'll go to the final type of loop, which is called the do while loop. Okay, so as I mentioned earlier, right, both the while loop and the for loop, right, the check for termination condition at the very top, which means the first time when you check these expressions, right, either expression 2 in this case or expression here, if this expression is false the first time itself, the loop is not even entered, right? So basically in these cases, both in the while loop or in the for loop that we saw, the loop may not even be entered. In this case, if expression 2 is false even at the very first time, the loop is not even entered once, right? Sometimes you may have a condition where you may want to enter the loop once at least. Okay, there are some scenarios where that is needed. So you have something called as a do while loop, where the loop is always entered once, and at the end of that you check the condition, right? So the structure is something like this. The syntax is you start with a do, then there's a statement. After the statement is executed, you check the while and this condition expression. This expression is similar to while loop, while structure also. Same. I mean, only thing is the check is done after going through the loop once. Okay. So if this expression is true, it will go back to the start and execute these statements. Again, the statement could be simple or compound, multiple statements in a curly braces. So as long as this expression is true, the loop will keep running. The only difference between while and the while followed by a loop and this do while loop is condition is checked at the end of the first iteration. So thing to remember is a do while loop will always run at least once. Okay, so that's the primary difference. You don't see it very often. Most of the time we see the while loop structure, but there are some scenarios where the do while is convenient to use, so it is there as an option, and you will see some code using do while where it is more natural to do that. Sometimes you may always want to do something first before checking things. So in those cases, the do while loop is useful actually. So this is, for example, I want to say print numbers from 0 to 9. Okay, I could have written it in a do while. I could have done it while loop also. But here, what I'm doing, I'm just starting with initializing a value 0 into the variable I. I'm just printing it, and I'm incrementing I every time. And I run this loop as long as I is less than 10. Right? The moment it becomes 10, it comes out. So it prints from 0 to 9. It could have been done with the standard while loop also or a for loop also. Just to illustrate how to write the code in this fashion if you're interested in doing that. Okay, so it's quite simple, nothing more complicated than this. So the only difference is it will run at least once actually. Now, we have seen loops. Now, I wanted to explain about this break statement. We saw the break statement in the context of switch, right? If one switch case matches, you want to exit out of the switch statement, we use the break statement, right? Basically, if the moment you put a break, it comes out of the switch. Whatever switch, the enclosing switch, it comes out. Similarly, in iterations also, sometimes if some condition is met, you may want to just exit the loop and don't go through anything beyond that, right? Maybe I wrote a loop for some number of iterations, but I want to stop when I find something, which is quite common. For example, a simple use case could be, assume I want to search for a particular character in a string. Okay, a string can be any number of characters. We're not covered string, but just for explanation, I might say I want to look for character X. If somewhere the character X ends, I don't want to continue searching. I just want to exit and say at this position I found X. Or assume there's a set of numbers that I'm running through. I want to stop the loop the moment I find the number 10. Right? So maybe there's a sequence of some 1,000 numbers, but I write a loop maybe to search for 1,000 because I don't know where I will find 10. But the moment I find 10, I don't want to search the remaining numbers, right? My only interest is to find the first 10 in that whole loop actually, in the whole sequence of numbers. So in that cases, the moment some condition is met, the moment I satisfy what I am searching for or whatever, I can just come out of the loop. The way to do that is by using this break statement. So inside your loop body, you will have some condition. If something is happening, if this becomes true, I'll just say break, which means the rest of the iterations need not be executed. The control will come to the statement which is following the loop. Is that clear? So this is typically used in those scenarios. So that's why I'm saying it is convenient to exit the loop other than by test at the top or bottom. So the break statement can be used to exit the loop. So if you have a nested loop, it will exit the innermost loop. Like for example, in the previous we had a 2 for loop nested conditions, right? If I have a break within the inner loop, when I say break, it will come out of the inner loop. So break will always take effect on the innermost enclosing loop or switch or whatever. Sometimes we have nested switches, but it will always work on that innermost thing, which is logical to expect, right? Okay. So that is called as a break statement. So here is, for example, there's an example of using a break statement. Okay, this is called as a string constant. I initialize to something. Okay, we'll see some of these things later again. For now, just understand string length is a function which returns the size of the string. Okay, so I'm calling this function string length. So 1, 2, 3, 4, 5, 6, maybe 11 or 12 characters are there. So I'm keeping this variable I to be 0. I want to check till the end of the string. Okay, and I keep incrementing I in every iteration. But what am I doing here? If I find a space character, right? Two single quotes with a blank embedding is a space character. The moment, and my MSG of I means it's like an array indexing. We'll see arrays later. Basically, the loop is trying to check every position in this string. The moment I see a space character, I want to stop the loop, which means I have found the character that I want. So the check is happening like this: as if in every iteration of the loop, if there is a blank character found, all I want to do is print a message saying blank space found at index, whatever position it was, right? So index starts from 0, 0, 1, 2, 3, 4, 5. Actually, in this case, when I come to I becomes 5, I find a blank character. So it will print this message and it will break. So the break here will come out of this for loop, which is nothing but the end of this whole program or the function that we have written. Is that clear? So this is the way to use a break statement. When your condition is met, you don't want to go through the rest of the iterations. So you just put a break statement, the loop will terminate there and come to the end of the loop. Okay. So this is an example of using the break statement. Similarly, we have something called as a continue statement. Assume you have a loop body, which is, say, a lot of logic is there in the loop body, right? But if some condition is found, you don't want to execute the rest of the loop body for that iteration. You want to go to the next element. For example, I am doing something. Let's take a simple example, right? I am examining the string, right? I see a character. When it is a lower space character, I want to do a lot of things for it. I may convert to uppercase, and I want to print a message. I may probably do something else. I may want to store it in some other array. Assume there are a lot of logic if I find a lowercase character. If I don't find a lowercase character, I just want to go to the next iteration of the loop. One way to do it, this is just a trivial example. If I find the character is uppercase, I will just say continue. So what will happen is it will go to the end of the loop and continue to the next iteration. So these are things which are convenient to do for some cases where you want to skip the rest of the logic in the loop and go to the next iteration. So continue, the effect of continue is to end the current iteration, but it will go to the next iteration. In the case of a break, the whole loop is terminated. Whereas continue, it just says go to the next iteration. Okay. So basically, and to again understand, how the difference is in for, while, and do while, right? In the while and the do while loops, this forces the test part to be executed immediately. Okay. Because the only thing you can control there is because the loop body is common, right? So if I say continue, it'll go and check that expression again, right? In the for loop, you have that expression 3 after the second semicolon, right? In the case of a for loop, it will jump to that expression 3, execute it, and then continue with the check again. Okay. So and again, continues only for loops. It's not for the switch statement. Okay, because it's continuation of the loop, so it doesn't work in a switch. There's no meaning for continue inside a switch. That's an error to use that inside that. Switch can take a break because it breaks out of the switch condition, but continues for loops actually. Okay. Generally, usages you don't see it that often, but in some scenarios it may be convenient to have that construct. So that's why the language supports it. But you will see breaks more often than continues in if you look at the large volume of code which is out there actually. Okay. Just to see an example of using continue statement, right? So assume I have a string, say some string is there, and I'm having a variable I and initializing it to 0. And again, I'm running this loop for the total length of the string. And in every place, what I'm checking is if there's a blank character here. Okay, if there's a blank character, I just do a continue, which means when I see this continue, what happens in the for loop? It will come and execute this. So I will get incremented, and then it will check this again. It will check the condition again. So basically, whenever I see a blank, I don't do the rest of the body of this loop. What is happening the rest of the body of the loop? I'm actually calling this a function called toUpper, which will actually convert the case. If it's a lower case, it will make it as an uppercase, and I'm just modifying that location to the uppercase value. I don't want to do it if I see a blank space. So that's why I'm saying if this is the case, I just continue. Okay. So it's just a simple example to see how to use continue. So the moment I see continue in a for loop, expression 3 will get evaluated and it will continue. Is this clear? How to use a continue statement? Okay. The final one in the control flow statement is called a goto statement. Okay. A goto statement is you can actually use a goto statement to arbitrarily jump to another position within the function. Okay. And it is essentially you tell the location by using what is called as a label. Label is nothing but an identifier with a colon after that, and you can place it anywhere in your C function. And within the C function, you can say go to, and it will directly jump to that position in that function and continue execution from there. Okay. But generally, it is not a advisable programming practice to use goto because it's not easy to understand code which has a lot of gotos because the control will keep jumping here and there. Generally, it's not considered to be a good structured programming practice, and you can almost write any program without using gotos. The only place where it is used is in some to jump out of some very rare error conditions and going to some cleanup kind of a code, you use it, but that also is very, very sparingly used. Okay, so it's generally not considered a good programming practice to use gotos, but the language does support it, so we're just covering it for completeness. So you can see an example here. So this is called as a label. So there is some function here, and label is nothing but you can say a name followed by a colon, which is like a place marker for this position in the code. Okay? And I have some lot of logic here, some complex logic in this function, and some disaster condition. This becomes true. I just want to say go to error handler. So some deep within this for loop, control will directly jump to this position, and here you might typically have some error handling code and then exit the function. Okay? So this is an example of how to use goto, but as I said, it's very, very sparingly used, and generally it's considered not a good programming practice to use a goto statement because it may be difficult to follow the logic when you have too many gotos actually. Okay, but that's how if you have to use goto, this is how you do it. You just say goto is a keyword and you give a label name. This error handler is called a label. Label is nothing but a name given to a position in the code. So you write a label name with a colon, and to call you just use the name here. Okay, so go to a label you give, control will jump to the position in the function actually. So we'll probably now just take we'll run through that online compiler. We'll just take a few examples and then see some loops that we talked about, right? I think for you to understand how this thing really works. Let's do some very simple exercises you can try more later. Let's take the simple case, whatever we tried earlier, right? Whatever we saw, we'll just see it in execution. So I'm just writing the same code here. Okay. Let's see how this works. Hope there are no errors here. So I'm again initializing this variable I to be 0, initializing a variable called C to this character constant small a, which essentially means a character within single quotes is nothing but the ASCII value of the character actually. Okay, and then this is my while loop. I'm just checking this condition I less than 26. So I is less than 26 initially, so it'll enter, it'll print the character for whatever ASCII value is stored in this character C. So and then I increment I and increment C and I run this loop as long as I is less than 26. Okay, so let's run this. Can you see we got this from A till Z, right? Okay, so we can, if we had started with say capital A instead of small a, if I had started with capital A, you will see it will now print capital A to capital Z. Can you see that it's printing capital A to capital Z? So if the thing is, if you had not probably incremented this I, right, if I had made this mistake, let's see what happens. You can see it printed capital A to capital Z, then some characters, basically the ASCII code, every ASCII code has some symbol, and then you got these. Then you're getting a lot of junk characters because those are not valid ASCII. Then again, some valid ASCII is going on actually. Okay, so it is essentially an infinite loop. Okay, the server would have killed my program by now probably, but so that is what happens if you don't terminate your loop properly, right? If I was not incremented, C was continuously getting incremented, so it was going through large number of values and it keeps printing the values. Okay, so now we cleaned up and it's printing properly again. Now we can modify the same logic to a for loop, right? How can we do that? We can move all these initialization into the for loop itself. Okay, so I will just probably declare, I mean, for simplicity we could have done that also, or we can put everything into the for loop. Let's try writing a for loop here. For, okay, I will just say int I equal to 0, comma, char C is equal to, say, small a. Then this is the first expression 1 I'm completing. Expression 2 is same, I less than 26. Then expression 3, I move all the incrementing operations here. So I can remove these two from here. Okay. So this should, and again I put this curly brace. So this is matching with this, right? Now let's try running this. Something is wrong. Probably doesn't take the syntax. Okay, it doesn't probably take the syntax. Let's move this outside the loop. Some compilers accept it. Let's do it in a more simpler fashion. Okay, let's only keep the initializations here. I think I can do only multiple variables of the same type with a comma operator. I can't put another. I could have I equal to 0, j equal to thing, but if I want to do a declaration, it doesn't accept it. Let's run this now. So you can see it prints the values from A to Z here. Okay. Now again, if I had modified it capital A, you will see the same output effect. It's the same thing. So this is an example of a for loop, right? I could have done many more logic here, but just to remember, you can have the initializations here, then the termination check, and you can put the conditions, whatever you want to modify at the end of loop, you can move things here actually. Okay. Now if I want to write a do while loop, which I can again do something similar. Let's say int I is like, say, I start with something like this. Let's try writing slightly different logic. So I'm starting with 26, right? So I'll say while I greater than 0. Let's see whether the logic is correct or not. So we're starting with 26 Z. I'm actually doing reverse. I'm printing from Z downwards now. Okay. So let's see whether the count is correct. 26 times. Hopefully it's correct. Let me see. Can you see? It starts from Z and it comes down till A. Okay. So in condition I put here is I greater than 0. In fact, I could have just said while I also, using the behavior, that anything non-zero is considered true. So I can just put while I. The same code will continue to work. Is that clear? So you can write the loop either way. You can increment the variable, decrement the variable, you can play around with it. So this is an example of how we can do a loop, which is things like this. For example, if I want to demonstrate the use of, say, break, right? So for example, I'm printing from Z. I want to stop printing, say, for some, this, just a trivial example. If I say I want to stop printing the moment I see character O, right? I can write something like this. Okay. So what happens now? It starts from Z. The moment after printing O, I want to stop, right? So let's see whether it works as expected. So it should now stop at O. Can you see that? The execution stopped at O. Okay, this is an example of using the break statement. Assume for example, if you want to have a different logic, I want to only skip printing O.